Let's take a look at implicit differentiation. Now, where this comes in handy is if you got a problem where you can't easily solve for y. All the problems we've seen up to now for derivatives, you've had y equals, or f of x equals. Well, let's take a look at our first example. And we got 4x to the third minus y equals 7x plus 3. I'm going to first work this with implicit differentiation, and then I'll show solving for y and doing it that way. With implicit differentiation, we take the derivative of everything where it's sitting. So we'll take the derivative of 4x to the third. We'll take the derivative of negative y. Take derivative of 7x. And a derivative of 3. And we're doing all of these with respect to x. Well, the derivative of 4x to the third is 12x squared. Now, here we're taking the derivative with respect to x, but this is really y. So we take the derivative just like normal. The derivative of negative y is negative 1, but since it's y and we're taking the derivative with respect to x, we have to add on a y prime. Now, a lot of books will put dy over dx here. I like to put y prime because it's easier for students to work with. Derivative of 7x is 7, and derivative of 3 is 0. So that gives us 12x squared minus y prime is equal to 7. And we have to get y prime by itself. So I'm going to take the negative y prime to the right side, and I'll take the 7 to the left side. So it becomes 12x squared minus 7 is equal to y prime. And that would be our answer. Well, this particular one, we could have actually done another way. We could have solved for y. I'm going to take the negative y over to the right side, and I'll take the 7x plus 3 and move it over to the left side. So we get 4x to the third minus 7x minus 3 equals y. And then take our derivative. I'll put the y prime over here, but take your power, put it out in front. So we got 4 times 3, lower our power by 1. Negative 7x, you drop the x, and the negative 3 goes to 0. So that would give us 12x squared minus 7. So this one, again, there was an alternative way to do it, besides using implicit differentiation. Let's take a look at our second example, though. We got negative 7x squared y minus 5 over y squared equals 2. Well, this I have no clue how we'd solve for y. I mean, we could get rid of the fraction, multiply everything by y squared, but then it becomes really hideous, and probably is no way to actually solve for y, easily anyway. Well, instead of doing that, let's just take derivative of everything where it's sitting. So I'm going to take the derivative of negative 7x squared y. Take the derivative of the negative 5 over y squared. And we'll take the derivative of 2. Now when I say take derivative of everything where it's sitting, I'm talking about what's separated by pluses and minuses. So that's why I took the derivative of this piece, and this piece. Now if you got negatives and numbers, you can put those out in front. So I can take negative 7 and put it out in front of this. And then we get x squared y. Here I'll take the negative 5 and put it out in front. Now here we got 1 over y squared. And on this side, I'll go ahead and take the derivative of that. Derivative of 2 is 0. Well, this is the product rule. We got something times something else. So this is P, and this is Q. P prime will be 2x, q prime. The derivative of y is 1, but since we're doing it with respect to x, we have to add on our y prime. So this will be p prime q plus p q prime. Negative 7 remains out in front. And then p prime was 2x times q, which is y, plus p, which is x squared, times q prime, which is 1 times y prime, just y prime. Now in this one, excuse me, we need is y to a power or x to a power. Can't have the y squared downstairs. So I'm going to take this y second power, move it up on top. When you do that, the sign of the exponent changes. When you move anything opposite of where it's at in a fraction, again, the exponent changes. So this becomes y to the negative 2. Okay, I'm going to go ahead and multiply negative 7 through. Negative 7 times 2 gives us negative 14xy. Negative 7 times x squared y prime gives us negative 7x squared y prime. Well, the derivative of y to the negative 2. Take your power, put it out in front, lower it by 1, so it becomes a negative 3. And since we're taking the derivative with respect to x, and this is really y, we're going to put on a y prime. Equals 0. So that gives us negative 14xy minus 7x squared y prime. And where in the world did that equals come from? Get rid of that. Okay, there we go. And then negative 5 times negative 2 gives us a positive 10. Y to the third y prime equals 0. And drop the negative there. That should be a y to the negative 3. Okay. Erase that. So y to the negative 3 y prime. Okay, let's get rid of the negative exponent. I'm going to take that y to the negative 3 back downstairs. So this becomes 10 y prime over y to the third is equal to 0. Now we want to solve for y prime. And always when you're solving anything, your first step is to get rid of fractions. So we'll multiply everything by the LCM of all our denominators. We only have one denominator, the y to the third. So we're going to multiply everything by y to the third. When I say everything, I'm talking about what's separated by pluses and minuses and so forth. So this gives us negative 14x, y to the third times y gives us y to the fourth, minus 7x squared, and we've got y to the third, and then y prime. Over here, the y to the thirds will cancel. And we're left with 10 y prime. And over on this side, y to the third times 0 is 0. Okay, so we want to get everything with a y prime on one side, everything else on the other side. So I'm going to take this, actually, and erase that. And I'll get everything with y prime on one side, everything else on the other side. So I'll take this negative 14x y to the fourth to the right side. Sorry, I was watching The Big Bang Theory. And that's where Sheldon is trying to learn Mandarin Chinese. And that is humorous. So I'm going to take that over. It becomes a positive 14x y to the fourth. And I'll focus now. Well, we want to factor out a y prime. And that gives us negative 7x squared y to the third plus 10 equals 14x y to the fourth. Well, I want to divide both sides by what's behind our y prime. So we'll divide both sides by negative 7x squared y to the third plus 10. 7x squared y to the third plus 10. Over on this side, these cancel. And we get y prime is equal to 14x y to the fourth over negative 7x squared y to the third plus 10. And let me save that. Maybe. There it goes. So BC, implicit differentiation, page 01. And let's look at our next problem. We have 4x y to the fourth minus x to the third y equals negative 5. Again, it's not very easy to solve this for y, so we'll just take derivative of everything where it's sitting. Now, if I got numbers and signs, I'll go ahead and put them out in front. So I'm going to have 4 times the derivative of x y to the fourth minus the derivative of x to the third y equals the derivative of negative 5. Well, this is a product rule. This will be P, and this will be Q. P prime will be 1. Q prime, take a power, put it on front, lower it by 1. But since we're taking derivative with respect to x, and this is really y, we have to add on a y prime. Now over here, let's say that's F and G. We're going to use product rule again. So F prime would be 3x squared. G prime, derivative of y is 1, but since it's y, we have to add on a y prime. Again, anytime you're taking derivative with respect to x, and it's y, then you have to add on a y prime. Well, this will be P prime Q plus PQ prime. This one will be F prime G plus F G prime. So 4 is out in front here. P prime was 1 times Q, which is y to the fourth, plus P, which is x, times Q prime, which is 4 y to the third y prime, minus, then we got F prime, which is 3x squared, times G, which was y, plus F, which was x to the third, times G prime, which was y prime. And then derivative of negative 5 is 0. Well, that gives us 4 times y to the fourth plus 4x y to the third y prime. Negative out in front flips sign of everything, so it becomes negative 3x squared y minus x to the third y prime. Multiply the 4 through, and we've got 4y to the fourth plus 16x y to the third y prime minus 3x squared y minus x to the third y prime. Now we want to get everything with a y prime on one side, everything else on the other side. So I'm going to take this negative 3x squared y to the right side, and this 4y to the fourth to the right side. So I'm going to have 16x y to the third y prime minus x to the third y prime equals 3x squared y minus 4y to the fourth. Remember, when you take anything across your equals, your sign changes. Now we want to factor out the y prime. And that leaves us 16x y to the third minus x to the third equals 3x squared y minus 4y to the fourth. Well, now we want to divide both sides by what's behind our y prime, which is 16x y to the third minus x to the third. And same thing over here. So divide both sides by 16x y to the third minus x to the third. And those cancel. And we got y prime is equal to 3x squared y minus 4y to the fourth over 16x y to the third minus x to the third. And that's our answer. And I definitely don't have space for another problem. And maybe I do beside it. Let me go look at what this one is. Yeah, I probably have space for that. So let's look at number 4. Got x squared y minus y to the fifth over y squared minus 3x equals 2. Now I could use a quotient rule on the left side. And I think my tablet just unplugged. Stupid thing. See if it's still working. There. Okay, I could use the a quotient rule on the left side, but there's an easier way. I can multiply both sides by y squared minus 3x. So I'm going to multiply this side by y squared minus 3x. What this will do is it'll get rid of the fraction. So if you can use some algebra to simplify it, go ahead and do that. And I'll multiply this side by y squared minus 3x. Now those cancel. And we got x squared y minus y to the fifth equals, and multiply a 2 through, and I got 2y squared minus 6x. Well, the minus 6x is easy, 2y squared is easy, the negative y to the fifth is easy. The only one that presents any challenge is this first part. This is the product rule. This will be p and this will be q. Something times something else. P prime will be 2x. Q prime, the derivative of y is 1, but since we're taking the derivative with respect to x, and it's really y, we have to add on a y prime. Okay. Now I'm not writing this down where you put the derivative around, but that's what we're doing, taking the derivative of everything where it's sitting. So this is going to be p prime q plus p q prime. So p prime was 2x times q, which was y, plus p, which is x squared, times q prime, which is y prime, minus, we got y to the fifth, take your power, put it out in front, lower it by 1, but since we're taking the derivative with respect to x, and it's really y, we have to add on a y prime. 2y squared. Derivative of that gives us 4y, but since again it's y, we have to add on a y prime. And derivative of negative 6x gives us negative 6. Okay, get everything with a y prime on one side, everything else on the other side. So I'm going to take this 4y y prime over to the left side, and this 2xy over to the right side. So I get x squared y prime minus 5y to the fourth y prime minus 4y y prime equals negative 2xy minus 6. Remember, you take anything across your equals, your sign changes. Well, we want to factor out the y prime. So over on the left side, that gives us x squared minus 5y to the fourth minus 4y equals negative 2xy minus 6. Now divide both sides by what's behind our y prime. So divide both sides by x squared minus 5y to the fourth minus 4y. And do the same thing on this side. this cancels. And we get y prime is equal to negative 2xy minus 6 over x squared minus 5y to the fourth minus 4y. And that'd be your answer. Let me save that. Let me shift in my seat a little bit here. I'll probably hit the tablet again and unplug it a few more times, but there we go. I had a minor accident over the weekend. I dropped a book on my the plug-in part, so now it's like that's great. My klutz. Let's take a look at this one. I got x squared minus y squared is equal to 9. And we got 0.54. And it says find the slope of the graph of the function at the given point. Well, our first step is to find y prime. Well, we use implicit differentiation here, and I guess I'll put this notation again. It's getting lazy in last problem. So take derivative of x squared with respect to x minus the derivative of y squared with respect to x and the derivative of 9 with respect to x. Well, this becomes 2x minus derivative of y squared is 2y, but we have to add on a y prime. Again, whenever you take the derivative with respect to x and it's y, you have to add on that y prime. And derivative of 9 is 0. Well, I want to solve for y prime, so I'm going to take the negative 2y y prime to the right side. So we've got 2x is equal to 2y y prime. Well, divide both sides by what's in front of our y prime, which is 2y. And we do that. The 2's cancel, these y's cancel. And we get y prime is equal to, these 2's cancel over here, and we get x over y. Well, step 2. Plug the x part of a point in. And change y prime to m. So y prime becomes m. I left part of that off. Plug in the xy part of our point. There we go. There it goes. This is x, and this is y. So we're going to plug in 5 for the x. We'll plug 4 in for the y. And this is the slope. Slope of the graph of the function at the given point. So it'll be 5/4. That's interesting. It's actually that right there. But let's take a look at the next one. We've got 2x to the third minus y squared equals negative 7. And at 1, 3. Well, again, we're going through the same steps because it wants us to find the slope of the graph of the function at the given point. So we'll take derivative of everything where it's sitting. Step 1, find y prime. So take derivative of 2x to the third minus the derivative of y squared equals the derivative of negative 7. Now 2x to the third, that gives us 6x squared minus the derivative of y squared is 2y, but then we have to add on the y prime. Again, anytime you take a derivative with respect to x and you have a y, you have to add on y prime. And derivative of negative 7 is 0. Well, we want to solve for y prime. So I'm going to take the negative 2y y prime to the right side. And I get 6x squared is equal to 2y y prime. Divide both sides by what's in front of our y prime, which is 2y. So I got 6x squared over 2y equals 2y y prime. Divide by 2y. Now these 2's cancel, these y's cancel. And y prime is equal to the 6 and 2 both divisible by 2. 6 divided by 2 is 3, specific. So we got 3x squared over y. Now our second step is to change your y prime to m and plug in the x and y part of your point. So put 1 in for the x, so we got 1 squared, and y is 3. Well, 1 squared is 1 times 3 is 3. And 3 divided by 3 gives you 1. Let me save that. Then we'll look at the next problem. Next problem is kind of a long one. Anytime you have a radical in them, they don't come out nice. Okay, so we got square root of xy. Now I'm going to go ahead and write it as xy to the 1/2, because I know I need to do that. Equals 7x minus y plus 5. And it's going to be at the point 1, 9. Still the same instructions. Find the slope of the graph. So we're going to take the derivative of everything where it's sitting. So we'll take derivative of xy to the 1/2. We'll take the derivative of 7x minus the derivative of y plus the derivative of 5. Well, this is a chain rule here. You got parentheses to a power. So you can take your power, put it out in front. What's inside the parentheses remains as is. Lower your power by 1, so we'll subtract 1 from it, and then we multiply it times the derivative of what's inside the parentheses, which is xy. And then equals, the derivative of 7x is 7, minus, the derivative of y is 1, but then we have to add on our y prime. And derivative of 5 is 0. So this gives us 1/2 and then xy, 1/2 minus 1 gives us negative 1/2 times, and I didn't leave enough room. Let me erase that. We'll come back to that. This is this would be P, and this would be Q. P prime would be 1, Q prime would be 1, but then we have to add on a y prime. So this is P prime Q plus P Q prime. Okay, now I'll do this one. So that gives us 1/2 xy to the negative 1/2 times, and then the derivative of this would be this formula, product rule. So we got P prime, which is 1, times Q, which is y, plus P, which is x, times Q prime, which is y prime, equals 7 minus y prime. Well, here we don't want a negative exponent, so I'm going to take that downstairs. So this becomes 1 over 2xy to the 1/2 times, that's y plus x y prime, equals 7 minus y prime. Well, I'm going to multiply these together. Basically, this goes up, just goes up on top. So we got y plus x y prime over 2xy to the 1/2 equals 7 minus y prime. Now we're wanting to solve for y prime, and pretty much wherever you are in math, one of your first steps in solving anything is to get rid of your fractions. So you multiply everything by the LCM of all your denominators. Well, I only have one denominator, so that is our LCM. So I'll multiply everything by 2x, or 2 times xy to the 1/2. 1/2. 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/2 1/ That's a single fraction there. That's why I multiplied it all by that. Over here, I'm going to multiply that times a 7. And then I'll also multiply it times the negative y prime. Okay, on this side, that cancels with that. That works out nice. And we got y plus x y prime equals 7 times 2 is 14. So we got 14 xy to the 1/2. Here we got a positive times a negative, so that's negative. 2 goes out in front. And then I got xy to the 1/2 and y prime. Okay. We're solving for y prime, so we want to get everything with a y prime on one side, everything else on the other side. So I'm going to take this negative 2xy to the 1/2 y prime over to the left side. I'll take the y over to the right side. So we'll have everything with y prime on the left side. Remember, when you take anything across your equals, the sign changes. So the negative 2xy to the 1/2 y prime becomes a positive 2. The y becomes a negative y. Okay, we're going to factor out a y prime. And we'll do that. That gives us x plus 2 xy to the 1/2 equals 14 xy to the 1/2 minus y. And then we'll divide both sides by what's behind our y prime. And so we got xy to the 1/2 divided by x plus 2 xy to the 1/2 equals 14 xy to the 1/2 minus y over x plus 2 xy to the 1/2. Okay, we're just about there. This cancels with that. And we got y prime is equal to 14 xy to the 1/2 minus y over x plus 2 xy to the positive 1/2. Now recall, in our original problem, we said square root of xy, which is xy to the 1/2, is equal to 7x minus y plus 5. One of the little tricks you'll see is they'll go through and they'll replace the xy to the 1/2 right here with 7x minus y plus 5. So we got y prime is equal to 14 times 7x minus y plus 5 minus y over x plus 2 times 7x minus y plus 5. By doing that, they get rid of the square root. So again, sometimes they'll use the original problem and plug it in at this point. Let me jot this down on a piece of paper because I'm going to scroll up. I was feeling kind of sick there when I started this video. Now I'm feeling the healing power of math start to take over. I should bottle this or something and sell it. Okay, so let me scroll up. Oh, that's nice. There we go. And how far do you need to scroll up? I could probably do it here. Okay, so we found that y prime is equal to 14 times 7x minus y plus 5 minus y over x plus 2 times 7x minus y plus 5. Well, 14 times 7 gives us 98 x. 14 times negative y is negative 14y. 14 times 5 is 70 minus y over x. 2 times 7x gives us 14x. 2 times negative y gives us negative 2y. And 2 times 5 gives us 10. Well, combine together like terms. So we got 98x. Negative 14y, negative y is negative 15y plus 70 over x plus 14x is 15x minus 2y plus 10. Okay, now we're ready to plug in our point. I'll go over here and look for it. See how our point is 1, 9? So this is our x and this is our y. And we'll change, this is step 2 now, we'll change y prime to m. So we got 98 times 1 minus 15 times 9 plus 70 over 15 times 1 minus 2 times 9 plus 10, which gives us 98 minus 135 plus 70 over 15 minus 18 plus 10. That gives us negative 3, 7. Up on top here, 98 minus 135 is negative 37 and 70. 33 over 7. Assuming I added everything correctly and multiplied everything and so forth. Now, I'm not doing much checking here because I don't want to make these videos too long. But truth of the matter is the odds of me not actually screwing up one little number here are very slim. But I think you get the general idea. If I want to take time, I would double check myself as I'm going through. But anyway, that's my excuse for any errors, you see. You know that or the sun was in my eyes. One of the two. Of course, I guess it'd help if it wasn't nighttime when I'm creating this. And time for my tablet to blow up, so let me bring up a fresh one. Now, radicals are always nasty. We hate to see those in calculus. It's just like, well, I don't. I love math, but most people hate them. Here we're back to a more normal one. And while we have radicals in our point, we don't have radicals in our problem. Now the instructions here say find equations of the tangent line to the graph at the given points. In this particular problem, we're only given 1 point. In the book, for the assignment for this, you'll probably have 2 points. Depending upon if addition changes and so forth. But anyway, we're finding the equation of the tangent line, so our first step is to find y prime. Well, take derivative of everything where it's sitting. So we'll take derivative of x squared. We'll take derivative of y squared. And we'll take the derivative of 25, all with respect to x. That gives us 2x. The derivative of y squared is 2y, but then we have to add on a y prime because we're taking derivative with respect to x and it's y. And derivative of 25 is 0. Now I'm going to solve for y prime, so I'm going to take 2x to the right side. So we got 2y, y prime is equal to negative 2x. Well, divide both sides by 2y. And we've got negative 2x over 2y. These 2's cancel, these y's cancel. These 2's will cancel, and we've got negative x over y. Well, we're still dealing with a point. I'm going to go ahead and write it down here because I'm going to scroll. Still dealing with that point. So our second step is to change your y prime to m, and then you plug in the x and y part of your point. That's x and that's y. So we're going to have negative x, so we have negative 2 over y, which is square root of 21. Well, we don't want a square root downstairs, so we'll multiply top and bottom by the square root of 21. Like this. Now when you do that, that gives us negative 2 square root of 21, and square root of 21 times square root of 21 is 21. Now step 3. Plug in the given point for x and y, and the m from step 2, and solve for b. Well, y we said was square root of 21. M was negative 2 square root of 21 over 21. X is 2, and then plus b. Well, this is square root of 21 equals, and negative 2 times 2 gives you a negative 4 square root of 21 over 21 plus b. Now take that over to the left side, and we've got square root of 21 plus 4 square root of 21 over 21 equals b. Now we need to get a common denominator, and if we're going to get a common denominator, they both should be fractions. So I can put square root of 21 over 1. And since this is 1, that's trivial. Our common denominator is the other denominator, which is 21. So we're going to rewrite each fraction with a new denominator. Now our second fraction we don't change at all, but our first one we multiply the bottom part by 21, so we have to multiply the top part by 21. Now, since they have the same denominator, we can combine together the top parts. 21 square root of 21 plus 4 square root of 21 is 25 square root of 21 over 21. Step 4. Actually write our answer down. We found m. M was negative 2 square root of 21 over 21, so we'll plug that in. X. And we found b, which was 25 square root of 21 over 21. So that's our equation of the tangent line. Not a very nice one for this one, but that'd be your answer. Let me save this. And bring that out. Stop this recorder. And then we'll stop our other recorder.